Yes. So in the case of mean value theorem, the very first one, the very first theorem or the statement that we are going to deal with, that is the Rolle's theorem. Okay. So first we are going through the statement of the Rolle's theorem, and then we go for the geometrical significance, and then for the particular problem as application of this Rolle's theorem. Okay. So one by one, let's see what the theorem is saying. That if x be a function, statement is saying actually, that if x be a function defined on a closed interval AB, where A and B are any constant numeric quantities, closed interval, this function fx is there, which is defined on closed interval AB, and satisfying the following condition. What the conditions are? First one, if x is continuous in the closed interval. Second one, if x is derivable in the open interval. And then if of a, that means value of the function at the point A and value of the function at the point B are equal. If these condition holds, then we say that there exists at least one value, say C, somewhere lies between A and B. Okay, somewhere between, it's not exactly between, but somewhere between A and B, inside A and B, there is a point C where or such that if dash C must be equal to 0. That means derivative of the function, given function fx at this point C must always be equals to 0. But first of all, we need to see that whether it's satisfying all these conditions or not. Okay, fine. And this is all about the statement of the Rolle's theorem. Now, according to the statement, we need to form the geometrical significance, what the statement is saying and what does it geometrically signifies. So let's have a look on the statement of the geometrical significance, and then I'll go for the whiteboard if it is required. Let's see what they are saying. First, have a look on the conditions of the Rolle's theorem, okay, for which the Rolle's theorem will be verified. First condition is fx must be continuous in the closed interval AB. So whenever a function is continuous in a closed interval AB, what does it signify? A function fx means there will be a curve. That curve will be a continuous in closed interval AB. That means if there are 2 points A and B on x-axis, and we are drawing a curve, we will be getting a continuous curve between these 2 points A and B. All right. Okay. And then what happens? Second one, what they are saying, fx must be derivable in the open interval AB. Now, can you tell me what does this derivative geometrically signifies? What this derivative, what the first, rather if you can say that the first derivative, what does it geometrically signifies? That is known to you in your previous classes. The derivative geometrically signifies what?
The maximum or minimum value.
Yeah.
Maximum.
Yes.
Maximum or minimum
No,
value.
that is not geometrical significance. Geometrically
That
Slope
means
of the
the
it
slope
tangent at
signifies,
will.
every point.
yes, slope of the
Yes.
tangent at the point at which we are finding the derivative. Okay, that means if it is derivable at every point in open interval AB, that means there exists the derivative exists at every point within AB, right? That means there is a tangent at every point between the curve at the point where on the curve between the point at A and B. We can draw the tangent, okay, between the points A and B. Now, furthermore, what they are saying that f of A must be equals to f of B. What does it signify? Look at the diagram. F of A means what? If this is the point A on x-axis and if this is the curve fx, then where will be the point f of A? On the curve. Corresponding to A on x-axis on the curve, there is a point that is the f of A. Similarly, corresponding to the point B on x-axis, there will be a point B on the curve. That will be your f of B. So these two values are equal. That means this height is same, f of A. This height signifies f of A and this is your f of B. So these heights are equal. That means we will be getting a curve like this, and this is a point f of A. This is a point f of B. So if these condition holds, what happens then? There is a point C at which f dash C must be equal to 0. What does it mean? There is a point C somewhere between A and B. Yes, this is your A, this is your B, then C is somewhere between A and B. It's not exactly between, no one is saying that exactly between, but somewhere between A and B. Okay, at which we will be getting f dash C is equals to 0. What does it mean if dash C equals to 0? F dash C, what it is? First derivative of the function fx at the point C. So geometrically, what the first derivative signifies, as just now I told you, that the slope of the tangent at that particular point at which we are finding the derivative. Is it? Okay.
Yes,
Yes,
ma'am.
ma'am.
Right. So slope becomes equals to 0. What does it signify? Slope becomes equals to 0 means angle
Parallel to
between,
x-axis.
yes, the tangent and the x-axis becomes equals to 0. That means what does it signify? That the tangent at the point C is parallel to x-axis. Clear? So this is all about the geometrical significance of the Rolle's theorem, right? So if the concept of Rolle's theorem statement as well as the geometrical significance is clear to us, then we are in a position to this particular problem. What the problem says, see, if fx equals to x minus a to the power of m and x minus b to the power of n, where m and n are any positive integers, prove that the point C in Rolle's theorem divides the line segment AB in the ratio m is to n. The point C in the Rolle's theorem divides the line segment AB in the ratio m is to n. That means what I need to do is I need to find out the point C at first. Then I need to check out whether whether we are getting the expression which divides the line segment in the ratio m is to n or not. Okay. So before finding C, the statement or the function must satisfies the criteria or the conditions of Rolle's theorem, right? So what are the conditions? Okay, let me go to the whiteboard. There I'll write the problem and then one by one we will check it out. Okay, what the problem we have written over there from Rolle's theorem?
Fx equal to x minus a to the power m.
Yes, fx equals to x
X
minus
minus
a,
a
yes,
whole
to
to
the
the
power
power
m
x
and
minus b whole to the power n.
n. All right, where m and n are positive integers. Okay, now I need to verify one by one the conditions of the Rolle's theorem. If it is verified, then only the point C exists. Otherwise, no point C will be there if it is not verified. Okay, so according to the first condition, fx must be continuous in closed interval AB. Okay, the interval is AB only over here also according to your problem. So fx must be continuous. Can you tell me how can I say that this function is continuous in closed interval AB? I'm telling you that it is continuous, but what is the reason behind that? If you can tell me.
Ma'am, if the limit exists.
If the limit exists, okay. I'm not going to find out the limit. There is a standard result. All we know that the polynomial functions are always continuous. Is it right?
Yes, ma'am. Yes,
Okay.
ma'am.
And as we can see, the fx whichever is given to you, it is a polynomial function. Okay.
Yes,
So
ma'am.
since fx is a polynomial function, since fx is a polynomial function, it is continuous. Okay. It is continuous, obviously on interval, closed interval AB. Okay. Now, number 2, what they have said that fx must be derivable in open interval AB. So let us take the derivative of fx. Or how much it is? F dash x will be m x minus a to the power m minus 1 x minus b to the power n plus n x minus a to the power m and x minus b to the power n minus 1. Is it okay? The derivative? Okay. Now look at the derivative. Obviously, this derivative will be having a finite value for x lying between a and b. If x lies between a and b, this derivative will always be having a finite value. That means if that it exists, it is derivable. Okay. If it diverges to infinity or minus infinity, then we say that it won't be derivable. Okay. Next condition, the third condition, final one, that is f of a. What about f of a? How much it is? F of a, that means x will be replaced by a. So what is your fx? At the point x equals to a?
0.
0. Similarly, f of b will also be equals to 0. So f of a becomes equals to f of b. So we can see that all three conditions are verified, and therefore we will be getting a point C for which f dash C must be equal to 0. Now, if dash C equals to 0, what does it implies? F dash C means in f dash x, x will be replaced by C. So let us do that. M C minus a to the power m minus 1, C minus b to the power n plus n c minus a to the power m and c minus b to the power n minus 1. That becomes equals to 0. Now from here, from this equation, I need to find out the value of c, right? So let us simplify. What is the common from these two parts? C minus a to the power, let us take common, and the common part is c minus a to the power m minus 1 and c minus b to the power n minus 1. Okay. Then the leftover part inside the bracket will be m into c minus b plus n into c minus c. All right, is equals to 0. Now look at the part. These are the multiples of these three, and that this multiple will be equals to 0. What does it signify? Either this will be equal to 0, or this will be equals to 0, or this part will be equals to 0. Now this will be equal to 0 and this will be equal to 0 is not possible. Why? If I make it equals to 0, C becomes equals to A. If I make this equals to 0, C becomes equals to B, which is not at all possible because our C is lying somewhere between A and B. Okay, it's not exactly A or exactly B. Okay, so these two are not possible. That means this expression will be equals to 0. So this implies m into c minus b plus n into c minus a equals to 0. So simplifying this, mc minus mb plus nc minus na equals to 0 gives us what? C, let us take it on one side. So m plus n C, and if I take it these on right hand side, so it becomes MB plus NA. So what is our C? C is equals to MB plus NA divided by M plus N. Now look at the expression. This is nothing but expression for the line segment joining AB, the point C, dividing the line segment in the ratio M is to N. Is it okay? So this is our value of C, which gives us the line segment, which gives us the ratio that the line segment, the point C dividing the line segment AB in which, okay, fine. So this we require to prove from the particular problem. Okay. So next theorem, next mean value theorem, which we are going to move on, that is Lagrange's mean value theorem. What the statement says, let us see at first, if a real valued function fx defined on closed interval AB satisfying the following condition. What the conditions are? Number 1, fx must be continuous in closed interval AB as similar to the previous one. Okay. And fx should be derivable in open interval AB. Then there exists a real number C somewhere between A and B such that f dash c equals to fb minus f of a divided by b minus a. All right. Okay, so it is similar to the previous one, only one condition is omitted over there, that is the third one in the Rolle's theorem. If here only there are only two conditions, fx must be continuous and it is derivable, then there exists a point c at which f dash c can be written as fb minus fa by b minus a. Now, another form of Lagrange's mean value theorem is also there, which is known as H theta form. Why it is H theta form, that you came to know after taking out the form. Okay, after going through the form. This H theta form we are going to utilize in doing the problems of Lmbt, Lagrange's mean value theorem. So let us take what the H theta form is. Nothing is there. It's just a simple substitution is there. What the substitution is, let b equals to a plus h. B in this interval, if it is replaced by some a plus h, okay, then any point between a and b can be written as a plus theta h, where theta lies between 0 and 1. Is it clear to all of you? I am replacing b by some a plus h, where h is an arbitrary small quantity, nothing else. Okay, I'm replacing b, the upper limit of the interval, by a plus h. Then any point between a and b, as we are taking it as c, what does c now? C will be a plus theta h, and obviously theta lies between 0 and 1. If it is, it should be, if it will be greater than 1, then it is a plus, it will no more be a plus h, it is more than a plus h, it becomes more than a plus h, it skips out the closed interval, upper limit of the closed interval. So that's why theta will always be taken between 0 and 1. Then if a function is defined, the same function as we have defined in the previous definition, the same function is now defined in the interval a and a plus h, satisfying the following condition. What the conditions are? Similarly, all the condition will be changed. Fx is continuous in a closed interval a and a plus h. It will be derivable in open interval a and a plus h. And there exists theta. This is not 0. This is theta, where theta lies between 0 and 1, such that f of a plus h equals to f of a plus h f dash a plus theta h. How this is coming, that if you need, I will go to the whiteboard to make you understand once again. Okay, so such that whatever we had, the expression we have written over there, that c belongs to ab, such that f dash c becomes fb minus fa by b minus a. The same thing they have written, but instead of b they have taken it as a plus h. Okay, now one more form is there we can utilize from here, or which can be obtained from here, that is Maclaurin's form. How we can write the Maclaurin's form? If in this expression we replace a equals to 0, if in this expression we replace a equals to 0, then it will be f of h. I have replaced x also. You may or may not replace x. Okay, so we can write it as fh plus f0 plus h f dash theta h, where obviously theta lies between 0 and 1. So this form, if I make a equals to 0 in h theta form, then it will be obtained as the Maclaurin's form, which is taken as like this. Now, according to the requirement of the problem, we are going to utilize h theta form, the basic form, or the Maclaurin's form of Lmbt, Lagrange's mean value theorem. Okay, fine. So let me go to the whiteboard once again to make you understand clearly. Sorry. Yes. So we are dealing with Lagrange's mean value theorem. Lagrange's mean value theorem. The statement is very easy. I think you have understood what the statement is saying, that there exists a function fx defined in closed interval ab, satisfying the following condition. What the conditions are? Number one, what they have said, that fx must be continuous in closed interval ab. Second condition, what they have said, fx is derivable. Am I audible to all of you clearly?
Yes,
Yes.
ma'am.
Yes,
Okay,
ma'am.
derivable in open interval AB, right? Then there exists a point C belongs to AB interval such that what? F dash C becomes equals to f of B minus f of A divided by B minus A. So this is all about the basic statement of the Rolle's theorem. Sorry, mean value, Lagrange's mean value theorem. Okay. Now I'm going for the h theta form. Let us take the h theta form of Lmbt, right? So h theta form of Lmbt. You need not to memorize, you just check it out, you will get it like this only. In h theta form, what we are doing is we are replacing b as a plus h. If we replace b as a plus h, then the interval becomes a plus h. And any point lies between a and a plus h can be taken as a plus theta h, where theta lies always between 0 and 1. I think this much is understood by all of you, right? We have replaced b by a plus h, then the interval becomes a plus h, and the point C is requirement according to the definition or the statement of the mean value theorem. So C is our now a plus theta h. Obviously, theta must lies between 0 and 1. So now we can reform the statement as number 1, first condition, if x is continuous in a plus h, if x is derivable in a plus h open interval, then if these two conditions satisfied, there is a point a plus theta h, which is our C now, or with 0 less than theta less than 1, obviously, such that what I can write according to this, f dash C. So I will write it as f dash a plus theta h is equals to fb. What is b now? F of a plus h. Fb minus fa. So fb means f of a plus h minus fa remains fa divided by what it will be, b minus a. That means a plus h minus a. Up to this much is clear? Okay,
Yes.
fine. So now from the denominator, a get cancelled out, and if I can simplify this, it will be h times by cross multiplication h f dash a plus theta h is equals to f a plus h minus f of a, right? So now if I write it in this form, it becomes f of a, let us take it on this side. So f of a becomes equals to, or f of a plus h also you can write, whatever, equals to f of a plus h minus h f dash f of a plus theta h. Is it okay what I have written?
Yes, ma'am.
Okay, now look at the form that I have given you as h theta form. Look at the form. F of a, instead of f of a, I have taken it as f of a plus h. So f of a plus h equals to fa plus h f dash a plus theta h. So we can write it in this form also. Let me reform it once more. So I can write f of, if I take it on this side, so f of a plus h becomes f of a plus h f dash f of a plus theta h. Is it okay? This form is known as your H theta form. H theta form. Okay, fine. Now in this H theta form, if I take A becomes equals to 0. If I take A to be equals to 0, so taking A equals to 0 in H theta form of Lmbt, what we will get? See, f of h equals to f0 plus hf dash theta h. Obviously, where theta lies between 0 and 1. This form, whichever is obtained, is known as Maclaurin's form. Maclaurin's form of Lmbt, right? So in this way, from the basic definition, just by some replacement or by some substitution, we can obtain two other forms of Lmbt. One is H theta form, which also we can utilize in our problem. Another one is the Maclaurin's form that will also be utilized as application in your problems. All right. Yes. So we are doing the geometrical significance. We are moving with the geometrical significance of Lmbt, right? According to the statement, what does it says that the first is, according to the first is, statement, the function fx must be continuous in the closed interval ab, right? So what does it mean? That means, say this be a curve or this be the coordinates, and this is your point A and this is your point B. So there must be a continuous curve, as we have taken earlier also, between A and B, right? Now next word, it is derivable. Fx is derivable in open interval AB. That means at every point between A and B, there exists a tangent. Okay, there exists a tangent at every point between A and B. Now, what the next condition is, if these two condition holds, then we must get a point C somewhere between the interval A and B, or somewhere between A and B. Say this is your point C. Okay, for which what the condition is, f dash C must be equals to FB minus FA divided by B minus A. All right. Okay. Now, what about our f dash C? What is f dash C? F dash C is the tangent at the point C. So this point is what? This point is what we are writing as this point. What are the coordinates of this point, if you can tell me? The coordinates are A
and f of a.
F.
A
Very
comma
good.
f of a.
Good. And what are the coordinates of this point? This is B,
B and
comma
B comma
FB.
f of b.
Okay, this distance is our A, this distance is FA, so it becomes AFA. This distance is our B and this is FB, so it becomes BFB, this point. Okay, now think about, because this part is known to us, because f dash C, the geometrical significance of f dash C is known to us. What is that? It is the slope of the tangent at the point C, at the point C on the curve. Okay, at the point C on the curve, the slope of the tangent. So this be the tangent at the point C. If this is the tangent like this. Okay, say this is the tangent at the point C. Now, sorry, think about this part. If I take the slope of the chord between these 2 points, say this is the A point and this is our B point. Now, find the slope of the chord AB. What about that? Slope of chord AB. All we know that if the points, the coordinate points are given to us, we can find the slope of the line joining these 2 points. What it is? If x1, y1 and x2, y2 are the 2 extreme points of a line segment, then what is the slope between them? y2
Y2
minus y1
minus y1 by x2 minus x1.
very
x2
good
minus
by
x1.
x2 minus x1. So what will be the slope? Say the points are now, the extreme points are now a and b. The slope between them will be, what is y2? Y2 is fb.
FB
So fb minus f of a divided by what is x2? b
B
minus a.
minus
So
A.
what is this? At the left right hand side, it is slope of the chord AB, and at the right hand side, it is the slope of the tangent at the point C. So these two slopes are equal. What does this signifies? These two
That
slopes
A
are
and B are
equal.
so close, man.
Slope doesn't signify that they are close to each other. What is slope
They are
actually?
parallel to each other.
Yes, very
They
good.
are parallel to each.
Yes, the slope is that the angle that these line segment making with the x-axis. So if they make the same angle with the x-axis, what does it mean? These line segments are parallel to each other. So slope of the chord, so I can write slope of tangent at C is equals to slope of chord AB, which implies that tangent at point C, tangent at C is parallel to the line segment joining A and B. All right, is it clear now what the geometrical significance, what it is saying? Okay.
Yes, ma'am.
Yes. So the very first problem on Lmbt that will be taking it as given to you as the form of Lmbt which is given to us as, if you can prompt me the problem over here. The form of Lmbt is given to you as FH equals to F0 that
F0
yes,
plus
F0 plus H F
in
dash
H F dash theta
theta H. Obviously, theta lies between 0 and 1. And the fx, whichever is given to you as a function,
Cos
which is
x.
given to you as cos x.
Cos
And we need to find limiting value of theta. Limiting value of theta as h tends to 0. Okay. So let us proceed using this form of mean value theorem. So what is your fx? Fx is given to us as cos x. So what about fh? Using this form, in this particular problem, it becomes, the form becomes, for the function fx equals to cos x, it will be cos h equals to, if 0 means 1, cos 0 is 1, plus h f dash theta h. What is f dash h? If fx is cos x, f dash x will be
minus sin
minus
theta h.
sin x. So it will be minus sin theta h. Minus sin theta f dash theta h. F theta h, f dash theta h. Yes, I'm taking that, right?
theta bedo मैंने
हाँ क्वेश्चन तो ठीक लिखे कि ना, let me check it out. Theta fx equals to cos x h लो f dash theta h. Okay, fine. Okay. Now, what we need to find out, the limiting value of theta. That means actually we need to find limit h tending to 0 of theta. The value has limit h tending to 0 of theta. Okay. So let me reform it as, I'm taking theta on the right hand side, then it becomes h sine theta h, and the left hand side becomes 1 minus cos h. Acha, what about 1 minus cos h?
2 sin square h by 2.
2 sine square h by 2. All right. Now, look at the left hand side. I can take the limit of, I need to take the limit as h tending to 0. Okay. So I'm making some modification over here. H sine theta h, multiplying and divide the expression by theta h. Okay. The expression remains same if you multiply and divide by the same quantity. Okay. Is it okay? Right?
Yes, ma'am.
So now
Yes,
this
ma'am.
implies it becomes theta h into h, it is h square sine theta h divided by theta h, and the right hand side will remain as it is 2 sine square h by 2. Okay. Now this implies just the simplification is left. Theta sine, only theta containing terms at the I'll keep at the left hand side, and rest of the terms I'll make it on right hand side. So 2 sine square h by 2 divided by 8 square. Okay, fine. Now what? Taking limit on both sides as theta as h tending to 0. So limit as h tending to 0, left hand side will be theta into sine theta h divided by theta h. Can you tell me what about the right hand side? Limit h tending to 0, sine h by 2 whole square divided by h by 2 whole square into 1 by 2. Is it okay?
Yes, ma'am.
Yes, ma'am.
Because this 2 I have taken in the denominator. Okay. And then I multiply it with 1 by 2 also. Okay. Fine. So now what about this limit? This is a standard limit.
1.
This
1.
becomes equals to 1. And what about this part of the limit?
That is
1.
also 1.
That is
So
also
theta
1.
is
So
half.
we are left with, after this step, this implies limit h tends to 0, theta, only theta will be left over there at the left hand side, equals to, this becomes 1. So we are left with half. So this we require to prove that limiting value of theta as h tending to 0 is equals to half using this form of mean value theorem. Okay, fine. The next problem, what it says that apply Lmbt to prove that the chord joining the parabola y equals to x square plus 2ax plus b, joining the points at x equals to alpha and x equals to beta, is parallel to its tangent at the point x equals to alpha plus beta by 2. So what does it signifies? The geometrical significance of Lmbt they have used in this, we require to use in this particular problem, right? Using the geometrical significance, what we require to show, actually what is given to us, we need to prove that the chord joining the parabola, there is a parabola, the chord joining the 2 points on the parabola, that is x equals to alpha is a point, x equals to beta is a point. Chord joining these 2 points on this parabola is parallel to its tangent at the point x equals to alpha plus beta by 2. So next, let us move on with this particular problem that prove that the chord joining the parabola, chord on the parabola joining the points x equals to alpha and beta is parallel to the tangent at the point x equals to alpha plus beta by 2. As we can see from here, we are going to utilize the geometrical significance of Lmbt to solve this problem. Okay. So according to geometrical significance, actually from the problem, we require to prove that this alpha plus beta by 2 is your point C. Okay. So let us move on one by one. First, we are going to verify whether Lmbt is satisfied or not. And then we will move on to find the point C. So let us proceed. So what is our function over here? What is your fx? In this particular problem, our fx is y equals to fx actually given to us. So fx is x square plus twice x plus b. Okay. So according to the first condition, what it is that the fx must be continuous in the interval alpha beta here. What is your interval? Interval is alpha beta, closed interval alpha beta according to the problem. So is it continuous in this closed interval? Yes, because
Yes.
this function is a polynomial function again. We know that polynomial functions are always continuous. Okay, so in this closed interval, fx will be a continuous function. Next derivative, let us find f dash x. How much it is? Twice x plus twice a. So obviously derivative also exists in the interval a alpha beta. It is having some finite values. All right. So we can write f dash c is equals to f beta minus f alpha divided by beta minus alpha. So let us proceed for that. What about your f dash c? This implies f dash c will be twice c plus twice a. What about our f beta? F beta is fx, x will be replaced by beta. So it is beta square plus twice a beta plus b minus f alpha will be alpha square plus twice a alpha plus b divided by beta minus alpha. Now just a simplification is left. So this becomes what? Beta square minus alpha square plus twice a, if I take common, it becomes beta minus alpha, and b minus b get cancelled out and divided by beta minus alpha. After simplification, what it will be? Beta minus alpha I can take common, so we are left with, and it gets cancelled out from the denominator, and so we are left with beta plus alpha plus twice a. Is it okay?
Yes, ma'am.
This fraction becomes beta plus alpha plus twice a. So now we are writing 2c plus twice a equals to beta plus alpha plus twice a. So what it becomes, twice a get cancelled out, and c becomes equals to beta plus alpha by 2 or alpha plus beta by 2, whatever you like. And c is the point we know according to geometrical significance at which the tangent is parallel to line joining the chord alpha and beta. In that point c, we require to prove it as alpha plus beta by 2. So this is all about this particular problem.